Hello, everyone. Let me just share my screen so that you can see what I'm talking about. Hello, everyone, once again. My name is Vanya Ivanova, and I'll be your moderator today. Welcome to our webinar. It is on STEAME tech resources and methods, and it is part of the STEAME project, which is about using artificial intelligence, dynamic geometry software, and virtual learning environments. The STEAME project is about using practical strategies for engaging students in creative critical thinking, and the project is preparing teachers to become STEAM educators ready for the future. Now, let me very briefly introduce our speakers. There are 3 speakers for today. The first one of them is Professor Todorka Glushkova. She'll be talking about integrating technology and artificial intelligence to enhance STEAME project-based learning. Our speaker is a specialist in e-learning and blended learning, and in her work she uses creative approaches, including educational games and digital resources. Our second speaker will be Associate Professor Marta Teofilova. Her talk is on using an interdisciplinary approach and dynamic geometry software to teach mathematics to university students. Associate Professor Teofilova focuses on inspiring creativity and critical thinking in STEAM education, and she is especially eager on bridging theory with practice and engaging her students who will be future teachers. Our third speaker is Professor Boyan Zlatanov, who will be talking about enhancing entrepreneurial skills through mathematical and financial modeling. He is a Doctor of Sciences, and in his work he focuses on improving pedagogical approaches and applications in mathematics education. So the 3 speakers will speak for about 10 to 15 minutes each. And as Andrew said, meanwhile, you're very welcome to make notes or to ask questions in the chat box. After their presentations, there will be also discussion time, and you could ask your questions then. Additionally, if you prefer, you could send emails to our presenters and discuss further their talks. So let me thank you for joining, and let's begin with our first speaker. Professor Glushkova, the floor is yours. I'll just stop presenting. Okay.
Thank you, Vanya. This module situated in Area 1 of the STEAM Teacher Competence Framework places a distinct emphasis on integrated project-based learning into STEAM education. The competences within this domain focus on enhancing educators' proficiency in employing project-based learning as a primary pedagogical tool. This includes the collaborative design, planning, and management of STEAM projects with teachers and with school administrations. Additionally, teachers are expected to possess knowledge of regional or national educational standards related to STEM, STEAM, or STEAMing. Sorry. And by applying new technological resources and methods, this module supports educators at every stage of project development. At first, from the initial phases of designing and planning of the project, throughout implementation and ongoing process and progress monitoring, and up to the evaluation of results and knowledge sharing. Through the focus of real-world applications and the integration of advanced technologies, educators will gain valuable skills to enhance the learning experience of students and themselves. We can see learning objectives according to competence framework. Our teachers, the teachers will be divided into two groups. For students teachers, they are in the level 1, and for service teachers in level 2. And two group of teachers reach the competence 6 and learning outcomes for this competence for the first group of teachers is define a productive use new technologies to facilitate students learning in STEAME project-based learning activities. Maybe these activities including artificial intelligence, virtual and hybrid learning environments, micro learning, and so on. And the second outcome is select and adapt digital content to support micro learning such as instructional videos and infographics. For the service teachers in level 2, this competence has some learning outcomes as demonstrate productive use of new technologies to facilitate students learning in STEAM, project-based learning activities. And the second is create, modify, and share digital content to support micro-learning, such instructional videos and infographics. The educational community recognizes the need for new approaches to STEAM learning, such as project-based learning, the applications of artificial intelligence tools and technologies, and the creation of interactive resources. One of the main tasks for several educational projects is the creation of teaching resources and methods. This is this module preliminary cultivates the following competencies from the STEAME Teacher Competence Framework. We see that the main competence is the competence 6 to support STEAME projects with the right learning environment and resources, and some secondary competences that are connected with the main competence. This is the competence 1, design and implement STEAME projects. Competence 3, monitoring STEAME projects and reporting. Competence 4, interdisciplinary STEAME projects. Competence 11, apply creativity and innovation in STEAME project-based learning activities. And competence 12, keep learning about STEAME projects and sharing of knowledge. The projects related with these competences and our main goal are many, but we will see some of them. For example, STEAME project, facilitate AI project, Biot learning, mileage learning, etc., etc. More of these projects are realized in the last years in European Union by using of different project directions. Artificial intelligence has the potential to change the way STEAME subjects and there are studied fostering deeper understanding, personalized learning experience, and more interactive and adaptive learning environments. Artificial intelligence in education is a term that refers to the integration of artificial intelligence in the context of education, in school education also. Some key applications of artificial intelligence in STEAME education are personalization of learning, enhanced problem solving, creative support in arts and entrepreneurship, data-driven teaching, encouraging collaboration and innovation, supporting lifelong learning in school and in university, ethical consideration, and many others. The Facilitate AI project is directly related to this goal. As a result of the work on this project, the consortium created a suitable Moodle-based educational platform with a variety of learning materials, learning creativity plans, and other STEAM relevant services and resources. We can see the address of this learning portal, and also all of these resources are free, and you can see some resources connected with organizing of some webinars, artificial intelligence activities inside and outside of the classroom, additional resources, and of course learning and creativity plans connected to with the main topic as artificial intelligence in STEAM education, artificial gamer, digital assistant in the class, and so on and so on. The ever increasing use of mobile devices by students outside of school gives us a reason to use these devices in the STEAM education. The fact is that big group of students use these devices outside of school hours for informal learning, using different apps, different games, and educational resources, educational websites. We can use these mobile devices for STEAMy learning in schools using an approach called a BIOT is bring your own device. It allows students to use their personally owned devices for different learning activity, and applying the BIOT method, BIOT approach for education gives students the opportunity to get knowledge at any time and any place and through any device according to their needs, their characteristics, their requirements, their goals, and other one. How BIOT helps to improve students' learning? The BIOT teaching approach with the use of the video materials and digital tools offer every student a personalized approach to learning where they control their own pacing and where they can see themselves as successful students and allow students to choose their own learning pathway. And for teachers, they can use videos to deliver their students information that can be extremely helpful in opening up class time. Learning materials and other information can be viewed before class, which allow for more practice and skill related activities in the classroom. These videos are accessible for all students and can be watched many times to assist with coursework and skill mastery. And this is the link to the web portal with videos and the other micro-learning materials. There are some ways to integrate these video files in the STEAM learning process. And we think that it is suitable to use in case of distance and blended learning, but also to introduce new topics in the class at the beginning of the lesson. And as a flipped classroom approach, this approach is so interesting. We know that it includes three main periods. One period before classroom and because lesson. In this period, students prepare to participate in the class activity. The second period is during the class when students practice applying key concepts and feedback. And the last period is after class when students check their knowledge and extend their learning. Also, we can see that according to the Bloom taxonomy, in these three periods in the flipped classroom is reached the all levels of the Bloom taxonomy. Before class, the students can reach the levels remembering and understanding, during the class applying and analyzing, and after class evaluating and creating. And by facilitating the incorporation of BITE learning principles and artificial intelligence technologies into STEAM education, it not only enriches the educational process, but also encourage more inclusive and more interactive educational environment. Thank you, Vanya.
Thank you, Professor Glushkova. And now let's move on to our next speaker. Now let us welcome Associate Professor Teofilova as she shares her insights with us.
Thank you very much, Vanya. I will talk today about how to prepare future math students to be effective as STEAM educators and facilitators. As I was inspired by the talk of Professor Makridis, I would like also to begin with some quotes, but I won't read all these quotes. They are by famous mathematicians, and they all underline the importance of mathematics in life and in science. I will read only the last quote by the famous father of analytic geometry, René Descartes. In my opinion, everything happens in nature in a mathematical way. And this quote goes on, but I will leave this for everyone who can read the presentation on the website of the project. As we all know, mathematics is a focal point in science and in STEAM education, as mathematical knowledge, skills, and competencies are applied to almost all areas of human knowledge. And also in art, everyone can enjoy the beauty of mathematics in paintings, sculptures, and the harmony of music. For these reasons, it is of great importance to prepare well math teachers to teach mathematics in STEAM environment. And to teach mathematics in STEAM means to apply mathematical knowledge in other areas, to construct mathematical models when presented with a problem, to obtain mathematical solutions of the model using modern technologies, to analyze and to interpret the obtained solutions in the context of the problem, and to go further, to inspire mathematical creativity and curiosity in the students. And to understand the pivotal role of mathematics in STEAM education, future math teachers have to be convinced that mathematics holds the key to solving problems. And what better place to start to convince them, as the first math they learn in university, it is usually higher mathematics part 1, which mostly consists of two disciplines, linear algebra and analytical geometry. And in this talk, I will share my experience in teaching those subjects to first year students. And in teaching, we can use software technologies to enhance and facilitate the process of teaching mathematics in STEAME classrooms. For algebraic computations, a computer algebraic system can be used, such as Wolfram Mathematics, Maple, as Professor Zlatanov will show in a couple of minutes, MATLAB, or other software like the statistical language and environment R, which is very suitable for matrix computation. For graphical representation of geometrical figures, a dynamic geometric software like GeoGebra, Desmos, or Geometry Sketchpad can be used. The first of this software have free online versions. And for preparing learning materials and presentations with mathematical symbols and formulas, a suitable environment can be used, such as LaTeX, Overleaf. The Overleaf environment is free and online. You can use the TIX package for graphics and Beamer package for presentations, or you can use the same R software with additional packages for presentations and generation of graphics. And I will show very briefly some examples which interconnect mathematics to other areas of science, mathematics and physics, mechanics. You can use the various vector products like the scalar product, the dot product, or the vector cross product to introduce mathematics in solving problems from mechanics, like the work done by forces, physical forces, or to calculate the torque, turning effect of a force. And these examples are taken from a solution manual, which I'm a co-author of. But you can, this is in Bulgarian, and you can access many resources like with such problems in English. For example, you can use this link below. Another example is of linear motion. You could use equations of lines in plane or in 3D space to calculate the speed, calculate the path of a point. You can use equations of lines and ellipses to solve problems from optics, problems connected to optical properties of conic sections, like the given one on the screen. You can use parabolas in problems of engineering bridges, like this one. Find the equation of the parabola of the shape of a suspension cable of a bridge in the given coordinate system, which is adapted to the bridge, to the positions of the bridge. You can use conic sections in solving problems of planetary motion. This is just one example. And I will talk here something about mathematics and art and dynamical geometric software in the moment. We all are familiar with the equation of a circle or the equation of an ellipse in coordinate system in the plane in the rectangle coordinate system. A generalization of this equation are the so-called Lamé curves, which are given with the equation below. And this generalization was very ingeniously used by the Dutch mathematician, inventor, designer, and even poet Piet Hein, who solved in the 1960s, who solved the problem of constructing a square in the capital of Sweden, Stockholm. the so-called Sergei-Stork square incorporates the forms of an ellipse and square, rectangle to be more precise. And this equation of a Lamé curve was also used by the Finnish smartphone producer Nokia to shape the central button of their mobile phones. Further, the formula of the so-called super-ellipse incorporating the ellipse and the rectangle was generalized by another mathematician and engineer and biologist, Johann Gillis. You can read about this in two of his books, Inventing the Circle and The Geometrical Beauty of Plants. Here is the formula of the super ellipse. And here is his generalization, which is called the super formula. And he used the super formula to generate a variety of shapes which are encountered in the nature. Here you can look at some of these shapes that one can obtain by changing the parameters in the super formula. And further, this formula was generalized in 3D. Here are some shapes, 3D shapes, which are encountered in nature and which can be generated by the 3D super shape formula. And I will show when I exit I'm sorry. And when I exit the full screen, I will try to show you here a free web tool you can use to generate super shapes and 3D super shapes here. You can play with the parameters. Here, for example, is not using a spiral. Here, the shape is using a logarithmic spiral or Archimedean arithmetic spiral. This might be very interesting for students to look at connections between mathematics and biology. And I will finish my talk with some geometry problems connected to loci of points in the plane. These problems can enhance the creativity of students and their critical thinking, and they can stimulate them to look for new properties of curves and geometrical figures. One example is to find the locus of points in the plane that are equidistant from a given point A and a given circle with center C. And you can solve this problem in a Cartesian coordinate system. And you can draw the solution given with formulas, analytical formulas. You can generate the solutions here in a dynamical geometric software like GeoGebra or Desmos. And you can look when the point is inside the circle, you obtain an ellipse. When the given point A is on the circle, you obtain a straight line. And when the given point is outside the circle, we obtain a hyperbola. So all these two conic sections are solutions of the problem. And everyone knows that a hyperbola and an ellipse are the two sides of one coin. And an excellent book on the topic of using dynamic geometric software in teaching geometry is by Professor Zlatanov, who will talk in a couple of moments, Developing Creative Thinking in Geometry Classes, and I strongly recommend his book. And also another good option for dynamic geometry software is the Geometry Sketchpad. And one member of our team, Professor Sava Grozdev, has a lot of papers on using Geometry Sketchpad, joint papers with Professor Vasilin Nenkov, and here are just two of their papers. And here is some topics of my experience in teaching linear algebra to first-year students, and some examples of applications of this mathematical theory. For example, the dot product, the scalar product of vectors. When I teach this topic, I introduce them to the concept of text mining and the vector space model of information retrieval. And I talk about Euclidean distance in genetics, phylogenetics. When I talk about matrix multiplication, I introduce them to graph theory and Markov chains. When we compute the inverse matrix of a given matrix, I introduce them to Hill matrix codes and Leontief input-output model in economics. And when we talk about eigenvalues and eigenvectors of a matrix, we talk about the Google PageRank and how Google gives the results of a Google search. We talk about spectral ranking algorithms for web mining. And I will end my talk again with a quote. This quote is by a famous American mathematician, Katherine Johnson, who was part of the NASA Mercury project and Moon program, and her calculations were critical to those NASA projects. We'll always have STEM with us. Some things will drop out of the public eye and go away, but there will always be science, engineering, and technology, and there will always be mathematics. And here are some sources for more inspirational quotes about mathematics and STEAME education. And with this, I end my talk, and I will try to unshare my screen. Thank you.
Thank you very much, Marta, for your most inspiring talk. And now let us invite Professor Zlatanov to deliver his presentation. Thank you.
Very much for giving me the possibility to work in an educational project. As you have seen, my main stream of scientific work is in mathematical analysis and geometry of Banach spaces, but it is very interesting for me to try to present to students mathematical problems that are applied in real life and that are that needed some extra knowledges to solve them. What I will talk tonight will be training students in the field of entrepreneurship. Actually a difficult word, but it means small business. A business held by one person or one person with just a few workers. We know that in history that all of these billion shares companies have started by one or just a few persons in a small garage. So that we have to invest in young people to have enough knowledge to start their own business and to produce new goods and to give new technologies to the world. Basic tasks which a small investor have to solve. If this is a big company, it has different different structures that in which structures they employ specialists which solve any problem with the knowledge that they have. But in the small business, the owner has to deal with all problems that arise. The first problem is the optimization of production process and realization of the produced goods in the market. But this is not part of my idea for giving basic financial education to the school students. The second problem is the optimization of the finances of their activity. What is needed for a person to make optimization of his finances? It is mathematics, basic finances, and information technologies. I will mention just two very typical problems that the owner of a small business will encounter in his work. Let us start with the first task. A person wants to buy a new piece of equipment, and when he goes to the store, the seller says him 200,000 paid right now, or you can pay it in 3 parts, equals 3 equal parts of 70,000, 3 years payment. At first glimpse, it seems that paying 200,000 is better if you have this money in your bank account. But actually, this problem is not a problem which is finalized to be solved. Every time I work with my students, I am explaining them that in financial mathematics, money are the same commodity as any other good. So they need to learn that if you have money, they can produce you more money. It is like if you have some seeds, you can sell part of them, and part of them you can grow up for the next year. The same is with the money. So any owner of a small business knows how much money he can gain by investing the money in his business. Let us suppose that at this point, the one who wants to buy this equipment knows that he can gain 6% profit compounded monthly. I'll present 2 solutions. The first solution is a very simple one. It can be calculated by hand or by a computer. The person has 200,000. He pays the first payment and he remains with 130,000. That will accumulate him some amount of money for 1 year. This amount of money will be equal to 138,000, and at the end of the first year, he has to withdraw 70,000 to pay the second transfer. And he remains with 68,000. At first glimpse, it seems that it is less than 70,000, but it will give him once again a 6% increase of his money, and at the end of the second year, he will have 72,000, so he will pay the final payment and will remain with $2,000 more. Therefore, he can optimize his payments and to pay 10,000 as amount more, but finally he will have much more money if he chooses the better payment process. What students need to know? They need to know the formula for compound interest rate. They need to know commands to define functions of 3 variables and basic arithmetic operations in algebra computer systems, which I'll illustrate just a little bit later. But there is another way to think on this problem. This problem is with the so-called discount value. How much 70,000? What is the present value of $70,000 today? We have to discount this so that our answer is that if we have today $65,000 and if we invest them with 6% rate increase of this amount for 2 years or for 12 months, for 1 year, 12 months, we'll need less than 70,000. The same is true for discounting this amount of money for 2 years or for 24 months. So we need to have $62,000 today in order to have 70,000 after 2 years. Therefore, we need to have at this moment this amount of money reinvested, which at the moment is less than 200,000, and it will make the payment of the requiring the new equipment. For the second solution, students need to know the formula for discount value, present value of a future payment, and the commands to define these functions. Now, going to the solution, I use the software Maple for better precision in the computations. I apply 20 digits, and I would like to present just 7 digits after the dot. We define the function as we know it. For the compound interest, the invested money, the interest per period, and the number of periods. So that if we have after the first payment 130,000 compounded with 6% year interest rate 12 times an year, they will produce $138,000. We pay the second payment and we leave with this amount of money, which are in the variable second. Make the next year some income with the money that we have. We repay and we have this value. By discounting, we have to put minus power to the minus to discount the value. So the same formula can give us how much money at each period we need to have so that to be able to pay for the 3 years. Therefore, the result is one and the same. The second comment is that not always we need to pay equal payments every time. We may have a contract so that at each interval to pay different amounts of money. And this formula presents how we can calculate which which type of payment will be better for us and to choose the cheapest one compared to the present moment. The second example is also very commonly met when a person with a small business wants to buy something. Let's say that he wants to buy a car. He goes to the car dealer, and the car dealer tells him, "Oh, you like this car? I can give you 150 discount if you pay right now, or 0.9% nominal interest rate per year, paid 6 months, which is better?" The previous problem, there was no interest rate for the paying in future, but there was a 200,000 payment. We don't know at the moment how much the car costs. If the one who wants to buy the car knows that he can earn 5% per year, compounded monthly, then making several calculations what will be the payment if a loan is issued. It is the unknown value of the car, and making several calculations, we finally end to a formula which says the discount divided by a function where we have the interest rate of the dealer, the interest rate that the buyer can accumulate if he has this money in his account and develop his business. And the result is the following. If the car is less than this amount, $15,000, then it is better to buy the car and pay it once in the buying, because you will have a 150 discount and it will cost 13,000. But if the car is more expensive than this amount of money, it is better to use the money for your company that will gain you a good profit, and at the end your finances will be you will maximize your finances and your profit. Again, it is very easy using Maple to define the function and to make the calculations. Maple can solve different problems. It may be the car costs 20,000. What interest rate of the dealer is suitable if you paid in one payment or paid for 60 months? So this is the payment, which is the this is the interest rate, which shows if it is less, it is better to pay it for 6 months. If it is bigger, it is better to pay it in one payment. Again, we can check with the same amount of money how much discount will be worth to think about. Or if we have the discount, the money, what is the interest rate which we can gain with our money that make the distinguishing between the two ways of payment. And the final is, I don't know, I don't see it here. It is how many months needed to be paid so that to optimize the payment. With the same numbers, it says that 45 months is the middle where there is no distinguishing between paying the whole amount of money with a discount or paying it in small future payments. Thank you very much. I hope that you found this interesting.
Thank you very much to Professor Zlatanov for your insightful presentation. And I would like to thank you once again for joining us. And I hope that you found the talks interesting and inspiring. I'm looking forward to seeing you in our future events. So thank you once again and have a wonderful evening, everyone.